Hey folks, Professor Gray here. Ready to talk to you about how to find a confidence interval for the mean when sigma is unknown. As mentioned in another video, often when we're finding a confidence interval for mu, that's the population mean, we don't really know what the population standard deviation is. So in those cases, we'll use the sample standard deviation and the student's t-distribution. Now, in some other videos, we talked about what all that entails and how to find critical values for a t-distribution. Here's the formula for finding a confidence interval when sigma, population standard deviation, is unknown. We'll leave the less thans and the symbol in the middle. We'll take x bar, that's the sample mean, and add the margin of error, that's E, and subtract the margin of error to get the upper and lower parts of the confidence interval. And E will be calculated using the formula shown on this slide. T sub alpha over 2, that's the critical value for the t-distribution, with alpha over 2, the area in the right tail, times S, sample standard deviation, divided by the square root of n, and n is the sample size. So let's do an example. Here's a scenario. In a test of the Atkins weight loss program, 40 people participated in a randomized trial. After 12 months, the mean weight loss was 2.1 pounds, with a standard deviation of 4.8 pounds. We'll find the point estimate, and using a 90% confidence level, we'll find the margin of error, and then use that to construct confidence interval for the population mean. Afterwards, we'll interpret it. Now notice, I'm finding a confidence interval for the population mean, but I do not know sigma. My problem mentions a standard deviation. But the way this is written, the standard deviation, 4.8 pounds, is coming from these 40 people, the 40 participants, not the entire population, which would be everyone who participates in Atkins. So, we'll have to use a student's t-distribution. We'll find the confidence interval using little calculator help first, and then I'll redo it, this time using the calculator's built-in statistics capabilities. So first things first, for number 20, find the point estimate of the population mean. Number 20 asks what the point estimate is. Well, the best point estimate for the population mean is the sample mean. In other words, we want to know the sample mean, or x bar. Well, careful reading of this problem tells us that the mean weight loss was 2.1 pounds, so x bar is going to be 2.1. Now for number 21, using a 90% confidence level, find the margin of error. For that, we'll use the formula on the previous slide. E is the margin of error. It's T sub alpha over 2 times S over the square root of n. I'll use parentheses on my S over square root of n just so it's clear that I'm multiplying. Alright, so I'll substitute in what I have and then solve for what I don't have. The first thing that I have is S. That's in the problem. So the sample standard deviation is 4.8. And I have the sample size. N is the number of people participating. That would be 40. So square root of 40. All that's left is T sub alpha over 2. Well, as mentioned in a previous video, I can go to my t-distribution critical t-values table. My degrees of freedom is n minus 1, so in this case that would be 39. And I'm making a 90% confidence interval. So the area in both tails combined would be the remaining 10%, or 0.10. Each tail would have 0.05 in it. Either way, you get the next to last column reading left to right. So I'll line that up with 39 and I get 1.685. So T sub alpha over 2 is 1.685. Again, I got that from the critical T value table. All right, now I'll use a calculator to find that value. And I can type it in exactly as it appears, 1.685 times, using parentheses, 4.8 divided by square root of 40. And I get my answer. So the margin of error for number 21 and for this confidence interval, once I round it, of course, and we'll round it to 2 places, is going to be about 1.28. There we are. That's my margin of error. Number 22. Construct a 90% confidence interval for the population mean. All right. The next thing we're going to do is we're going to put together the point estimate and the margin of error to find our confidence interval. So for the lower bound, that'll be x bar minus e. That's less than mu, what I'm estimating, which is less than x bar plus e. So 2.1 minus 1.28 gives me 0.82, and 2.1 plus 1.28 gives me 3.38. So 0.82 is less than mu is less than 3.38. You might also see that in interval notation. If you do, it would appear like this. You'd want to be familiar with both types of notation. Now that we've done that using the calculator as little as possible, let's do it using the calculator's built-in capabilities. Here's how. I go to Stat, and then I use the right arrow to go to Test, and I'll go to T interval. It's number 8 for me, T interval. So now that's a confidence interval using the T distribution. Once I'm there, I can select either data or stats. If I had been given these 40 weight loss numbers in a list, I would use data. I would put those in my list, list 1 probably, and I would use data. I would keep the frequency at 1 and then I would put in my C level, that's confidence level, and press calculate. Since I don't have the actual numbers and just have summary statistics, I go over to stats and press enter. It's not already there. And then I can fill some things in. X bar comes from the problem. That was 2.1. SX is the sample standard deviation, which was 4.8. N is the sample size, 40 people. And C level is the confidence level, which is 90%. Now, I go to calculate, press enter, and I get my answer. If I compare that to the answer I got earlier, I'll find they are the same thing when rounded to 2 decimal places. 0.82 to 3.38. Number 23 says to interpret the confidence interval. We would interpret it by saying this. We are 90% confident that the mean weight loss on Atkins is between 0.82 and 3.38 pounds. Again, we are 90% confident, because it's a 90% confidence interval, that the mean weight loss on Atkins, that's from the problem, is between our lower bound 0.82 and the upper bound 3.38. Here's a few words about confidence and precision. How confident are you that the average adult male weighs somewhere between 10 pounds and 1,000 pounds? Well, it's got to be somewhere in there, right? I would be pretty confident in that. How confident are you that the average adult male weighs somewhere between 170 and 172 pounds? Well, we would be less confident of that, because it's very likely that we could be wrong. See, there's a trade-off in confidence and precision. If you want to be more precise, that means you have a smaller range of data, smaller interval. Well, if you're going to have a smaller interval, then you're going to be less confident because your interval doesn't collect as many data points. If you want to be very confident, then just make a really big confidence interval, make a really big range. But it won't be very precise. So there's a trade-off there. You can have a lot of confidence, but you won't have much precision. You can have a lot of precision, but it's going to hurt your confidence level. Yeah, the challenge is to balance between confidence level and precision. Get a confidence level that is healthy and large enough for us to feel good about, while at the same time getting results and getting a confidence interval that's narrow enough for those results, those numbers, to be of value.